Okay, hello everyone, and welcome to week of, here we have 6th of May. So some of you commented or responded to the whole May the 4th Star Wars Day post, and then also I was reminded that actually yesterday was also a holiday in Mexico. It's called Cinco de Mayo. It's May 5th, and it's I think it's like an independence holiday or something like that. No one. I I grew up in America, and I don't think we really know what Mexico's holiday was all about. Just like here, I'm sure there are many Turkish holidays I didn't even know about. But what we did do is we often would eat Mexican food, tacos and fajitas and stuff. So if you did that yesterday, if you ordered or cooked at home fajitas or tacos, then you were celebrating a Mexican holiday yesterday. So anyway, I don't know why I talked about all that, but there's two things I want to do today. So one is I want to initially talk about the UML activity diagrams. I realized when I put together that assignment, I had put that assignment together earlier this semester, and I realized that when I posted it that I had not yet gone through an activity diagram example here in this course. So I'd like to do that so that you can have a good understanding of what an activity diagram is and how to make one and how to analyze code, or how to analyze, rather, not even code. What we really want to do is we want to analyze an algorithm. Okay, and so then also we will in the second hour, then we will talk about generics. This week, according to the syllabus, we're supposed to talk about generics today. Okay, and then we'll do that, and hopefully that should be it. The 2 hour, we'll do 2 hours today, and then that should be it. I actually expect low number of students here today because the second and fourth year students are having exams this week, so I expect that many of them will be there instead. Okay. All right, so let's get right into the whole activity diagram. So let me do this. Let me share. Where are you? There we go. We'll just share that screen, actually. All right, so here, let me skip on over to this picture instead. So this one instead. So what I've done is I've created here two methods that will do something. So one is the calc something, and this is the calc something else methods. Okay. Now, the thing about these is that this code is available under the lecture examples, and I put this in here not so much for you to try to figure out what this algorithm is doing. In fact, that's not really all that important. I can tell you this is a very convoluted, very complex way of doing something really simple. And if you're interested in trying to see how well you can look into an algorithm and figure out what it's doing, this might be a good at-home assignment for you. But that's not what we're here to do today. What we're here to do today is I want to take this code and I want to make it into an activity diagram. Okay. And so what I'm going to do, I'll pull up this diagrams.net. Okay. And I'm going to share this with everyone. I'm going to share this diagram. Create new. Let's see, UML. Is that activity? Yep, activity is here. There's a few different ways to do it. I'm going to do. Oh, can you see the screen? Let me take a look here. Okay. Dokon, it looks like you may be the only person that's having this, so sorry, but hopefully it'll show up on the video, and then you can you can watch it on the video later. Okay, so let me see. So the few different formats for it. What I'm going to do is, let's use this one. And what I'm going to do is I'm going to put it into, where are you? There. I'm going to put it into the folder for this course. Let me just put it here. Oh, I meant to call it something else. I didn't want to call it Untitled Diagram. That doesn't make any sense. Okay. So there's a couple of different ways that ways that you can note different things. You can have these different things like actions and objects. So this is really, actually, I'm going to delete this because this is actually much more complex than what I want you guys to do for your assignment. What I would like you to do is, it more kind of a flow chart style. Let's see, where's my decision? There you go. All right, so we have an end and we have a start. And the main thing is that these lines here represent kind of the flow of how you move from one point to another. So we're going to have a start, and then we are going to have, we could have an action. Where are you? Like, not object. Where are you? Like an activity. It's called an activity diagram. So we could have an activity, we could have a condition, we could have a join at the end of a condition. There's all manner of possible things that could happen. Okay, so let's take a look at the code. So here, this would be considered an action. Anytime that we reach a point where we just have some code that does something, executes a line in some way. Okay, that's an action. And so what we'll do is we'll come back over here and we'll put an action, or an activity. You can call it an action or an activity. And we can connect them together, and then that way, as we move this around, notice that the lines stay connected, and that's nice, right? That's what we want. Okay, and we can give this like this. Notice that we don't have to make it specifically Java code. Okay, we don't have to make this like compilable Java code, because the main thing of what we're trying to do is we're trying to represent an algorithm. We're trying to represent an algorithm in a way that can be taken to any language, and we could do the same thing in some other language. All right, so now we've done our line. Now, an if, is that an action or is that something else? What do you think that is? What do you think an if statement is? Right, it's a condition, exactly. So we're going to bring a condition in here. Okay, and again, we can connect it here. We can move it up here. Now we have a no and a yes condition. So that's like true, false. So you don't have to call it yes, no. We could rename it. We could call it true. We should call it true, false. We could call it yes, no. We could call it, in some places we might say a 1 and a 0. So a 1 for true, a 0 for false. There's all kinds of ways that we could label this, okay? Come on. Doesn't want to, there we go. I like true, false personally, but not everybody does, and that's okay. All right. So the question is, okay, so then what do we do if it's true? Now, sometimes what we might do is we might format it differently. We might format it like this. And the reason why is that if there's equal amounts of more stuff that's going to come over here on the true side as the false, we might do it like this. Okay, we might do it like this so that it just kind of balances the diagram out. Okay? And the nice thing about a diagramming tool like this diagrams.net, one of the nice things about this is that, again, we can make all the connections first, and then we can move stuff around to try to make it look better. Okay, we don't have to make it look good as we're doing. Okay. So if the condition was true, what happens next? Well, now we encounter a while loop, right? What's a while? Yeah, it's another condition, right? So I can copy and paste this. Oh, one other thing I forgot to do here is that first condition, a is greater than 0. We can put that into here. Okay. All right. And here we might say, as part of our start points, is we could pass. Where are you? I don't see it. Oh, there it is. Okay, dispatch. So dispatch is another way of saying to pass a value into this activity. So notice here you have the dispatch here. Notice we have a dispatch and we have a return. So that's if we pass something into a method or into an activity and we return something from. This notation, this dispatching return, is especially useful for things that aren't just simple Java code like this. It could be if two processes in, let's say, a what's it called? Two processes in like a parallel processing system between two processors, and they kind of send each other messages. This could be something that could be useful in that if we're diagramming that. Okay, so we're going to pass in an integer a into our method. Okay, and then that way, once we get to this point, we know what a is. Oh, okay, a is this integer that's being passed in. Okay, and the condition that we didn't look at yet, the while loop, a is greater than 1. Okay. So we're going to go to that. And what happens if a is greater? We're going to do something, right? Let me move some stuff around here, actually. Okay, if a is greater than 1 is true, we're going to do what? What did we call these? All right, while is a loop. That's. But what is this? What is return? RET plus plus a minus equals 2. Right, those are activities. These are these activity things. So we're going to bring another one of those in here. Okay. And the nice thing is we can put and the reason why, let me say one thing too here also is a equals a. The reason why I'm writing it differently from the Java code is because what happens if this is what we really want to do, right? We want to do this RET value gets added 1 to it. We want this A value gets 2 subtracted from it. That's what these notations mean, right? But we might want to take this algorithm and put it into a language that does not have that that syntax. We might bring it over into Python, who might not have that syntax. We might want to bring it over into some other language that doesn't have that syntax. And so this way we know what it's trying to do. We've defined what it's trying to do. Okay, and we could even not even put it code style like this. We could have written it such as this: set return to return plus 1. Right? We could even use pseudocode like that. That would be okay too. But for this, I'm going to go ahead and just set it up like this. Okay. So now I'm going to move this into place. Connect it up. Move it up. Whoa. Where did that come from? I don't know where the black arrow went. Okay. And now I don't know where my arrow went. Oh, I know what this arg. I know what just happened. This needs to be over here. I don't know where that arrow keeps going. Okay. Anyway, we're fine here. Okay, so once we've done that, what does our loop do then after a equals a minus 2? What does our loop do? What happens after a equals a minus 2? Right, we go back and we check this again, don't we? That's what a loop is. So what we can do is we can move this over to this side, move this over to here, and there you go. Now we're looping back, right? We're going to keep doing that over and over again until this is false. Oh, and I need a false. Okay, so now I have a false condition. What happens with the false condition? Does it go into here and do this other loop? What happens once this loop is false? Right, then we skip over here and we end up here at this end point, right? Now, what I'm going to do for while I'm making this with you, we could go ahead and put that down here at this end point, but I'm just going to leave it hanging there for right now, because I'm going to show you that this is actually going to be joined with something else. This is going to be joined with the output of this if statement. Right. Another nice thing about these diagramming tools is notice that this while loop looks very similar. It's very similar to this while loop, right? There's a lot of similarities there, aren't there? So what we can do, we can take this whole loop here, okay? And we can Control C to copy, or you can click or right click on it and click copy. Right, and then you can Control V. Now have that whole thing there, or you could right click and paste. Okay. All right. So notice there's only a few differences, right? There's only a few differences that we'll have to change. We'll have to do less than -1 instead of greater than 1. we'll have to do return minus minus instead of return plus plus. So that'll be return equals return minus 1 instead of plus 1. And then finally, we will need to do plus equals 2 instead of minus equals 2. So, all right, but everything else is the same, right? All right. Now, one thing I would do here for making things look nice is I will switch this to the outside. So there's what's called symmetry. There's no requirement for this, by the way. There's nothing that says you have to do it this way. Let me come on. I want to move this over to here. I want to move this off for just a second. Okay. So now notice that in both of these, where's my, do I have a false? Ah, there it is. Oh, there it is. Notice that both of these come to the same place, right? The next thing we're going to do is this is the result of right here. This is where the if statement and the else statement where they meet back up, where the flow comes back. So we start here. We're going to either take this path or we're going to take this path. But when we're done with either this path or this, we're going to end up here. Okay. So what we can do is we can join. Right. This is one way we can represent the joining. And then that becomes the end. And then the final thing is we tell it we have a return, right? We have something we're returning out of the method. And we can say, okay. So it's returning this RET value. And notice that by connecting everything together, you know, I can move stuff around, right? Now this looks really jumbled and crazy, but I can put it where it needs to be. And now this is a visual representation of how we would represent this algorithm. Okay, so I'm going to save this as a picture. I don't have enough time to go through this one in class today. This other one is calc something else. It's a little bit more involved with, you know, nested if statements and the while loop, but generally follows the same pattern. It generally follows the same pattern of how we just did that with the calc something. But where activity diagrams are really useful is not in taking existing code and writing a diagram from it. That's useful on its own, because then that way we can show our customers, we can show our users a visual representation, a visual way to understand what's happening inside of our code. But where it's really useful is to be able to take a diagram like this and produce code from it. All right, so let's put an example here. No, not you. So just a simple example. Okay, we're gonna say, let's say this is a method and we're passing, let's see, what can we pass to it? Oh, I got an idea. We're going to pass a object into our method. Okay. And then we're going to say, okay, this method is inside of the department class. So let's say that we could show that. Let's see, where are you? I think it's, maybe it's in a different, not you. I'm not seeing it. You could put it inside of a class here. Maybe frame is what I'm thinking of. Yeah. Yeah, we can do it that way with the frame. Okay. And what you could do is you could tell it where it is. You could say it's in the department class. Okay. All right, so we pass a teacher object into this, and we want to check, okay. Oh wait, I need to send you to the back. Okay. So we're going to check and see, is the teacher that's being passed in the current department? Yes or no? And if yes, well, no, why are you doing this to me? Okay. Okay, and if yes, then we want to set the chair to be T, the teacher that we passed. This hopefully is reminding you guys of a method that you've written recently, right? And if no, if the teacher that we passed is not in the department, then we want to do something else, right? We want to do what? What was it called? Department. Called the department mismatch. Now you could make this an activity since that's going to be some code of some kind. There's a couple of other options. We could make it like an end or something like that. But the thing with this is that there is no flow out of this, right? Because department mismatch is an exception situation, is an error situation. It does not flow from there to the end of this method. It ends the method. Terminates the method unnaturally, right? So we could have, there's a couple of different ways we could note this. I think you could say return would be an option. You could just leave it hanging like this, because again, until this exception is handled, this does not flow anywhere. Okay. Well, once you've set the department chair to be whatever the teacher object is that you've put, that ends it, right? That ends our method. All right. So what method is this? Right. So it's the set chair method, you could have you show it a couple of different ways. All right. Pretty simple. All right. And then what we can do is we can take this, right? We can take this activity diagram and we can create code from it. So I'm just going to come down here to the end. This is not compilable anymore, but let's imagine we were in the department. We could say, does it return anything? Nope, it doesn't return anything. Now, where we will know that, remember, we talked about this before in the class diagram. So the way we would show that is here in a separate diagram, you would have the department with all of its list of fields and stuff, and then in the methods, you would have one of the methods would be set chair with a teacher that we are passing and a none return type. We don't return anything. So this would show up in your UML diagram, your UML class diagram. This would be how you would take that method and then show it in your UML activity diagram. Okay, so we'll take this. So I can leave it there for now, actually. And this method, remember, the only thing we say in the class diagram is the name of the method, any parameters that it gets sent, and any return types, and the return type that it sends back. Right? That's the only thing that shows up in the class diagram. We said there's no indication, there's no anything in the class diagram that talks about what the algorithm actually does. Right? It's only its name, its parameters, and its return. That's it. I guess technically also its visibility here. Okay, like if we wanted to make it private, but most methods are public and most fields are private. All right. So this activity diagram, that's where we start talking about what does this method actually do? Okay. All right. Omer, to answer your question about setters and getters, I would say if you were doing this program, if you were doing this for like an actual customer, yes, you would show it in that diagram. For this assignment, for assignment 3, I would say the only get or set methods that I would expect you to show would be those that do more than just return a variable or assign a variable. So if you let's say if there was no exception that happened here, there's no if statement or anything like that. Like let's see, what's an example? Like instead of the set chair, what is it? There was a set name, right? Where the only thing, right. There is no if statement. There's no exception in the set name method, right? It just does this, right? If your set method would not look like this, don't worry about making a diagram for that. Okay, you don't need to make a diagram for that. If your what is it? If your get method would simply look like return. Come on. If your get method looks like this, don't worry about making a diagram for that. Okay, that you don't need all that. All right. But if there's more complicated aspects to it, then you need to make a diagram for that. Okay. So don't do this. Don't make this. Don't make this diagram. All right. Okay. So it returns none, so we don't have anything returning, so we don't have to put anything there. The method just ends. Okay. And what we can do is we take this and we begin to return. Hold on, first it's public, so it's public. We don't need to call it static because it's not a static method. It returns none. It's a void method. Its name is setChair teacher. Now then we go to the activity diagram and say, okay, we're going to name that teacher T. A good friend named T a long time ago. Then we're going to say, okay, we're going to have an if statement, right? So this will become an if statement. And I'm putting in here because that's not, you guys know this is not real Java code, but that will probably be some other method, right? There will be some other method we may need to call to get there, right? Right. If T in this chair, which is the local variable or the class variable, equals T. So we're setting chair to be T, and we're done. We've done that. But we have an else that we need to deal with, right? And put all that in my head. So now we've taken the flow chart and we've created this Java code with it. Okay. And again, like I said, this needs to be replaced with correct Java code to somehow check if the teacher is in the current department. This also needs to be replaced with proper parameters to pass. Okay. Let's see. So a couple of questions here. Difference between constructor and normal method. Same thing. If it's complicated, if your constructor simply assigns the variable values and that's it, then you don't need to necessarily, or I would say if your constructor calls the set method for the different variables and then that's it, then you don't need to show the constructor for your diagram. You do need to in the class diagram though, if there's more than one constructor. So if you have like a constructor of one, if you have a no argument constructor plus some other multiple argument constructors, then you need to list them in your class diagram. But I would say unless your constructor does something strange for some reason, does something complicated, then no, you don't need to show it in the activity diagram. Oh, yeah, Omer, that's what I was saying, was in the class diagram, if you were making this for an actual client, customer out there for like work, they would expect to have those. I will not expect, I'll instruct the grader to not expect you to have those, again, unless they are complicated. So basically, any method that you put into here should have an activity diagram and vice versa. Okay, so only if it does some weird stuff. Only if it does some not weird. Only if it does complex operations involving if statements and exception handling and stuff like that. should you worry about putting it into an activity diagram or into the method section on a class diagram. Okay. Okay, I think I'm back. Okay, yeah, so for this assignment, that if you have a very simple get set method, if you have a field listed here, that you have a get and a set method. Yes, go ahead and do that so that we know which, because you'll need to identify which classes use those custom exceptions. They should have a relationship for those exceptions that they use. So yeah, go ahead and add them to the class diagram. Okay. Any other questions? Those are some good questions, guys. Good. I'm glad you're listening and pay attention. Again, like I said, I will take these and I will export them as images and put them in the class materials folder, hopefully today. All right. If no other questions, then we'll go ahead and take a break now. We'll come back. We will begin our discussion on generics. All right. See you in about 10 minutes.